Our research group has worked on several projects. In this presentation, we will show a brief introduction to each of them. Our robotic head focuses attention on several people based on different vision and sound stimuli. We use a competitive neural network that receives the different stimuli, such as whether a person is talking or looking at the robot. The competition is implemented in a dynamic competitive network, followed by a habituation network that prevents any one person from monopolizing the conversation. Finally, a short-time memory layer network allows increasing the duration of small stimuli to seek the robot's attention. For the robot learning by demonstration problem, using skeleton elicitation models, posture classification neural networks and Markov models, we obtain the sequence of postures that a person performs in an exercise. This sequence of postures is transformed into an animation sequence that a robot reproduces. Our research has also evaluated how to detect the exercise through string matching, as well as the evaluation of its performance. Our group published the cross-validation voting technique, an ensemble modeling technique that allows to improve the classification results of a large number of individual classifiers. The training dataset is divided into several disjoint validation groups that are trained by early stopping of the validation accuracy. They are then integrated using voting techniques. The method allows the use of classifiers of the same or different types. The method has been tested on supermarket products, industrial defects, hieroglyphic classification or activity recognition, showing its improvement in all cases. Recognition of archaeological artifacts is one of the applications of object classification and detection networks. In our work, we use the detection results of two YOLOs to identify the figure and sequence of hieroglyphs of Egyptian funerary statuettes. In addition, we created an ontology to connect the results to Europeana. The one-shot learning problem seeks to be able to classify samples into different categories for which only one example is available. It is a type of problem within the group known as few-shot learning, where models are sought that are able to classify samples when there is very little labeled data. Our research focuses on the use of ensemble models of binary classifiers using Siamese networks trained with disjoint class groups. Our computer vision activity recognition system uses the features obtained by a convolution model and also certain semantic aspects, such as the relationship between objects that are close to a person. Our model uses three branches. The first one extracts the features from an inception convolution model. The second branch extracts the articulations of two persons. The third branch extracts the position of the objects. Our classification results were 86% against the STARE dataset, composed of more than 64,000 videos. The recognition of people's activity through the use of sensors and positioning beacons allows us to know what multiple people are doing inside the home. This technique is less invasive than the use of computer vision since the sensors are deployed in the home. We use supervised techniques based on bidirectional LSTM and GRU networks but also ensemble models. In addition, we have also addressed the problem using unsupervised learning and Markov models. On the other hand, we have deployed humanoid robots that are integrated with the recognition system. By means of rule-based cognitive systems, these robots help elderly people. Our models obtain a test accuracy of more than 90% in the recognition of activities.